Hello student, welcome back. Last class we have already discussed this question, and in this class we will discuss trick of this type of question or type 1. Type 1. First formula, sin inverse sin theta is equal to theta if theta belongs to close bracket minus 92 plus 90. Second, cos inverse cos theta is equal to theta if theta belongs to 0 to 180. Tan inverse tan theta equal theta if theta belongs to minus 92 plus 90. Similarly, cot inverse, sec inverse and cosec inverse. Previous example, sin inverse sin 3 pi by 5. Same question. Answer is 2 pi by 5. Now we will find using this. Trick. First, this angle does not belongs to minus 90 to plus 90. Then what will we do? First, we have to convert to acute angle. We can write pi minus 2 pi by 3. Yes or no? If you solve this pi minus 2 pi by 3, you will get 3 pi by 5. Next, sin inverse sin 180 minus theta, sin theta. First formula, sin 180 minus theta, this is equal to sin theta. Now this angle is belongs to minus 90 to plus 90, then we can cancel sin inverse sin. If this angle belongs to minus 90 or plus 90, then we can cancel these two terms and the result is theta. Now this angle belongs to minus 90 to plus 90. Now we can cancel sin inverse sin and we will get 2 pi by 5. Are you getting my point? Next example, second question, and trick is cos inverse cos theta equal theta if theta belongs to 0 to 180 and this angle does not belongs to this quadrant. First, we have to convert this angle to acute angle. We can write 2 pi plus pi by 6. If you simplify this two term, we will get 13 pi by 6. Next, cos inverse, and we know that 2 pi is nearly equal to 0. Cos pi by 6. Cos 2 pi is equal to cos 0. Now this angle belongs to 0 to 180 and we can cancel these two terms and we will get the result is pi by 6. Similarly, next question, cos inverse sin 13 pi by 6. First step, cos inverse sin 2 pi plus pi by 6 and 2 pi is nearly equal to 0. No doubt this angle belongs to 0 to 180, but these two functions are not same. If these two are same, then we can cancel these two terms and the result is pi by 6. But here first we have to convert pi by sin into cos. So in this case, we have to use the angle 90 degree. If the functions are different, we have to use 90 degree. If the functions are same, we can use 180 degree to simplify this angle. Now we can write sin, instead of writing pi by 6, we can write pi minus pi by 2 minus pi by 3. Yes or no? Pi by 6 means angle is 30 and pi by 2 minus pi by 3 means 90 degree minus 60. This is equal to 30 degree. Instead of writing pi by 6, we can write pi by 2 minus pi by 3. Sine 90 minus theta, that is cos theta. And this is equal to pi by 3. This is our result. Now, do one thing. Example number 3 from your APC book. This example number 3 contains 5 bits. Like this type of questions, we can do it. Page number 100 and 101, either 101 or 99. Type 2, second type formula. Sine of sine inverse x, this is equal to x if mod x less than 1. Next type of formula, sine of sine inverse x equal to x. Here x is the value. If this value less than equal to 1 mod of x, then this formula is applicable. Similarly, cos and tan, and the rest are cot, sec and cosec. Only these 3 are important. We can skip cos, tan and sec also. Example. First example, sine of sine inverse 1 by 2. This 1 by 2 is less than 1, so answer is 1 by 2. Sine of sine inverse 2. This is impossible. Why impossible? Because this 2 not less than equal to 1, and this is not an angle, so we can convert to acute angle. This is a value, so we cannot convert into 1 or less than 1, so it is not possible. Suppose tan of 2 tan inverse 1. This is not equal to 1. Why? Not this 1 belongs to real number, but there is a 2 between. There is a 2 between 10 and 10 inverse. But in this formula, there is a no element, no value between 10 and 10 inverse. There is only one coefficient 1, but here is 2. So it is not equal to 1. Next, type 3. Sine inverse minus x equal to minus sine inverse x. Sine of minus theta equal to minus sine theta. This is our first year concept. Similarly here, sine inverse minus x equal to minus sine inverse x. And similarly, cosec inverse minus x equal to minus cosec inverse x. Tan inverse minus x equal to minus tan inverse x. And the rest are cos, sec and cot. Minus x equal to pi minus cos inverse x. Here pi minus sec inverse x, and here pi minus cot inverse x. I will give you proof of first bit and this question. Bit 1 and bit 2. First bit, left hand side. Sine inverse minus x. Let this is equal to theta and minus x equal to sine theta. Or you can write x equal to minus sine theta. We know that minus sine theta is equal to sine of minus theta. We can write sine of minus theta instead of writing minus sine theta. Then take the sine into left hand side. The sine becomes sine inverse x. Now multiply minus both sides. Theta equal to sine inverse minus x and theta equal to minus sine inverse x. Hence sine inverse minus x is equal to minus sine inverse x. This is the proof of first bit. Proof is not required. Type 4, cosec inverse x is equal to sine inverse 1 by x. If we want to change cosec into sine, and we know that reciprocal of cosec theta is sine theta, first year trigonometry formula. If we want to change it, then its value also change, that is 1 by x. Similarly, sec and cot. Cot contain two cases depending upon the x. If x is positive, simply tan inverse 1 by x. If x is negative, we have to add a pi plus pi. Then type 5. Type 5 is important. Sin inverse x plus cos inverse x equal to pi by 2. Tan inverse x plus cot inverse x equal to pi by 2. Similarly, sec inverse x plus cosec inverse x equal to pi by 2. Then type 6. I will give you proof of this type 5. Tan inverse x plus tan inverse y. There are two cases depending upon the value of xy. If xy is less than 1, you have to use this formula. If xy is greater than 1, we have to use this formula. Generally, we are using only this formula. That is tan inverse x plus y divided by 1 minus xy. If it is greater than 1, we have to same formula, but we have to add a pi symbol. Next, second bit of type 6. Tan inverse x, that is plus, it is minus. Tan inverse x minus tan inverse y. Tan inverse x minus y by 1 plus xy. Then tan inverse x plus tan inverse y plus tan inverse z. That is tan inverse x plus y plus z minus xyz whole divided by 1 minus xy minus yz minus zx. Next, type 7. 2 tan inverse x. It contains three formulas depending on the trigonometry. One is tan, one is sine, one is cos. In tan, tan inverse 2x by 1 minus x square. In sine, sine inverse 2x by 1 plus x square. And this is cos inverse 1 minus x square divided by 1 plus x square. Type 5, 6 and 7 is very important. And type 8, select 2 sine inverse x in terms of sine and in terms of cos. You can skip it. Also type 9, you can skip it. Also this is skip. Only type 5, 6 and 7 is very important. And type 9 contains 3 sine inverse x, 3 cos inverse, 3 tan inverse x formula in terms of sine, cos and tan respectively. Last formula of this chapter, type 10. We have already discussed tan inverse x plus tan inverse y. Now we will discuss sin inverse x plus sin inverse y. If it is plus, it is plus. If it is minus, it is minus. Sin inverse x times root over 1 minus y square plus y times root over 1 minus x. This is also very important. Cos inverse x plus cos inverse y. Cos inverse xy. If it is plus, we have to put a minus sign. If it is minus, we have to put a plus sign. Alternate symbol. But in case of sine, symbol is same. Only type 5, 6, 7 and 10 is important.